Welcome to Technical AI, where the future of artificial intelligence is created.
Large language models, LLMs, they feel like magic, right? You ask a question and boom, a thoughtful, coherent answer just appears. But what is actually going on inside that black box? Well, today, we're going to peel back the curtain and see exactly how the trick is done.
So, to get our heads around this, let's start with a little thought experiment. Imagine you stumble upon a movie script. You can read all the lines for the human characters, but wherever the AI assistant is supposed to talk, the page is just ripped off. Your one and only job is to fill in those missing lines. So, how would you do it? You'd read the lines before the terror, right? You'd get the context, the vibe of the conversation, and then you try to guess the most logical next word. Then the next, and the next. You'd be predicting the dialogue, one single word at a time. Now hold on to that idea, because you've just unlocked the fundamental secret of how these chatbots work.
Yep, that's it. All of this complex, seemingly intelligent behavior, it all boils down to that one core task. At their heart, these incredible systems are really just very, very sophisticated machines for predicting what word comes next in a sentence.
So here's the official definition for you. A large language model is basically a giant mathematical function. You feed it some text, and its entire purpose in life is to calculate which word has the highest probability of coming next. That's it. Everything else, from writing an email to composing a sonnet, springs from that simple goal. But how does it actually make that choice? Well, here's a cool little twist. The model doesn't just pick the single most obvious word. Instead, it generates a list of probabilities for all the words it knows. And to keep the conversation from being boring and predictable, it sometimes rolls the dice and picks a slightly less likely word. That little bit of built-in randomness is the exact reason you can ask the same question twice and get two totally different but equally valid answers.
Okay, so if it's all a prediction game, how does a machine get so unbelievably good at it? Where does it learn all the rules of grammar, context, and even humor? Well, the answer is it learns from us. From pretty much the entire internet. These models learn by chewing through a truly mind-boggling amount of text. Books, articles, websites, you name it. To put the training data for something like GPT-3 into perspective, get this. If you were to sit down and read it all 24/7 without any breaks, it would take you about 2,600 years. And the newer models, they're trained on even more. The brain of the model is made up of billions of values called parameters. The easiest way to picture these is to imagine a gigantic machine covered in billions of little tuning dials. Each dial adjusts the model's behavior in some tiny way, and the whole point of training is to get all of those dials turned to the exact right positions. So, how do you tune billions of dials? Through a massive, repetitive feedback loop. The model starts out with all its dials set to random, so it just spits out total nonsense. Then, you show it a sentence from its training data, but you hide the very last word. The model takes a guess. You compare its guess to the real word, and then a clever algorithm goes back and nudges all those billions of dials just a tiny bit to make the correct word a little more likely next time. Now, just do that trillions of times. This whole process requires a staggering amount of computational power. I mean, if you could somehow do 1 billion calculations every single second, it would still take you over 100 million years to do all the math required to train one of these big models. It's a scale that's almost impossible to wrap your head around. Now, this kind of insane computation is only possible thanks to a huge breakthrough that happened back in 2017. It's an architecture called the transformer, and it is the engine that powers basically every modern large language model you've ever used. See, before transformers, models had to read text just like we do, one word at a time from beginning to end. It was painfully slow. Transformers completely changed the game. They're able to soak in all the text at once, processing it all in parallel. This is a job that's perfectly suited for modern computer chips called GPUs, which are brilliant at doing tons of things simultaneously. This was the key that unlocked today's massive scale. So what's actually going on inside that transformer? You can kind of think of it as a three-step dance. First, every word gets converted into a long list of numbers. That's called an embedding. Second, all these lists of numbers talk to each other to figure out the context using a special mechanism called attention. And finally, the model uses all that contextual information to find much deeper patterns in the language. This attention mechanism is the real secret sauce. For instance, if the model just sees the word bank, it's ambiguous, right? Does it mean a place for money or the side of a river?
By talking to the other words in the sentence, words like water or flow, the attention mechanism can actually adjust the numbers for bank, so they specifically mean riverbank. It's how the model achieves a true understanding of context. Okay, so we've got a machine that is an absolute champion at predicting text. But being good at auto-completing random stuff from the internet is a very different skill from being a helpful and, more importantly, a safe AI assistant. And that requires one last, absolutely vital step. Training really comes in two major phases. Phase 1 is that pre-training we just talked about, where the model just gobbles up the internet to learn the patterns of language. But phase 2 is all about alignment, and it's often done using a technique called RLHF. Here, the goal changes completely. Now it's about making the model a useful assistant, and that means bringing humans back into the loop.
RLHF stands for Reinforcement Learning with Human Feedback, and it's pretty much what it sounds like. In this phase, you have actual human workers who are interacting with the model. They'll ask it questions and then rate its answers. They give good answers a thumbs up and correct the bad ones. All of that feedback is then used to reinforce good behavior, fine-tuning those billions of dials even further. It's how you teach the model not just to predict any text, but to predict text that is helpful, harmless, and aligned with what we want.
And this is where it all gets a little mysterious, because even though we designed the architecture and the entire training process, the model's most amazing abilities, its fluency, its reasoning skills, are what's known as an emergent phenomenon. We didn't explicitly program them in. We can't point to one of those billion dials and say, oh yeah, that's the one for writing poetry. These skills just emerge from the sheer complexity of the system in ways that we still don't fully understand.
So there you have it. We went from a simple word prediction game to a massive system that can write, code, and converse with a fluency that is, frankly, uncanny. We've managed to build a machine that has learned the patterns of human language. But that leaves us with one heck of a question, doesn't it? We've taught a machine to talk, but do we really have any idea how it thinks?
Thank you for watching. For more insights into AI and technology, be sure to like and subscribe to Technical AI.